So welcome back to CodingCEO, the channel where I empower you to become the CEO of your own coding journey. In today's video, we will be exploring the JVM data areas with instance and local variable concept. So starting with JVM, a Java virtual machine. We already discussed this concept. It is a part of a JRE. JRE is nothing but it stands for Java Runtime Environment. We have written our Java program and save it as a .java file, right? Then Java compiler, the Java C, convert it into a class file, .class, which is nothing but we will also refer it as bytecode. And this bytecode then passed to JVM to execute, right? So JVM is a part of JRE, which is responsible to execute our Java program. Okay, so talking about JVM in detail, JVM has some data areas. What are they? There are in total of 5 data areas. One is method area, another one is stack area, third one is heap area, fourth one is PC register, and fifth one is nothing but native stack. So we have in our memory a RAM, and in this RAM we have our JRE. With the help of JVM, one area in our RAM is assigned to JRE, to our Java code, which is JRE, and it starts executing our Java program. So how the execution of our Java program takes place? JVM basically takes help from these 5 data areas to run our program. Just take an example, as in your cupboard, you keep your t-shirts, shirts in one part, the jeans, pants in another, watches, handkerchief in another part, important document in another part. Likely that the same way JVM stores information or data in different areas and run the program successfully. So in method area, JVM put entire Java code, okay, the byte code, the .class file. In stack area, methods execution will happen and local variables are stored. We will be see the concept of local variable after this. In heap area, object creation, instance variable, static variables are stored. In PC register, for every statement we need some address, right? If you write a statement like just say int a equal to 5 with ending with semicolon. Okay, so this statement we need to store the address of a in somewhere. Okay, so where it is stored? The PC register. So for every statement, the address is stored in PC register. For native stack, if we want to use any third-party API, we will be seeing the third-party API in further videos of this Java tutorial series. But if we want to use any third-party API in our Java program, the native stack come into the picture. So local variable and instance variable, right? We have let's say int age equal to 18. Is this age variable a local one or instance? What is your answer? So age is nothing but a local variable. Age can also be the instance variable. How it is possible? Let's see. Okay, we have our class, let's say demo, int age, int cost, okay, and we want void to display this variables sub age. Okay, here age is nothing but our instance variable. Okay, cost is also a instance variable. If we have another example, let's say class demo, int age void display int cost, and we want to print the cost. So here age is instance but cost is a local variable. Okay, local means it is local to that block only, it is local to that method, but this age we can use it throughout our class, right? We have written a for loop, right? For int I equal to 0, I is less than all. Okay, so what is this int I equal to 0? It is also a local variable because this I is only dedicated for this for loop, the for block. Just see how memory mapping will happen. Okay, so we have this class dog with variables int age and int cost and a method called as bark, and there is some program written in this method. Okay, so we have a stack and heap area from our data areas. As I already told you, stack is there for JVM to execute the methods. So main method is also a method. So main method is nothing but the stack frame or main frame. In the main, if we create a object Okay, let's say dog dg equal to new dog and dg dot bark. So let's say we have created a dg reference variable for our dog object and we have called dg dot bark method, right? So first of all, our object will be created in our main using our execution of mainframe. So there is some dg address is stored to refer the object creation of heap. Okay, in that we have age and cost. As these age and cost are instance variable, their default values are created. For int, default value is 0. So 00 for age and cost is created in heap. There must be some address for this and the default values are also generated. So the whole class is there in our method area, right? As needed, it goes to the stack and heap. Remember this line: anything or everything which is there in your Java code, if that has to be executed, that has to be brought to the stack area only. Then and then only it will get executed. This concept we will be covering more on threading, the multi-threading concept. So from this example, you will be knowing JVM starts execution of main. First of all, the JVM creates stack frame or main frame in the stack data area. Okay, the DG object, DG reference variable is created for our dog object. It will be referring directly our address. After creating DG, it will be directly creating our instance variables. First is age and another one is cost. Default values are stored as it is the instance variable. There is one method called as dg.bark. So bark method will be created. All the methods are created in our stack data area only. So bark method is created, and when we call the dg.bark, it will be go to void bark, execute whole program, and then come back to the end of the main. And as this is the end of our main, whole thing will be closed. Okay, so let's take the example of stack and heap. So in previously we have already created our dg.bark method. Let's assume in the dg.bark, in the void bar, we have a string called as name. So we have returned the class dog, int age, int cost, void bar, and in this bark method we have written a string name. We have executed our main method, created one object, mainframe getting created in our stack area, right? In that mainframe, our main method is executing. So first statement is dog dg equal to new dog, right? So dg variable is created and there is some address. Okay, let's say xyz. So this xyz address is nothing but for our object creation. So object is created. So this is xyz is nothing but the object address. We have age, we have cost. Age has 0, cost has also 0. After the statement we have, let's say we don't have this print statement, we directly have dg.bark. So bark method is created in our stack area, right? But what do you think the value of the name? Default value is not given for this name variable, as this name is local app. But why default values are there for age and cost? Age and cost are instance variable. So instance variable, they can be used throughout our class. Name can be used throughout our method only. So if we print dg.age, dg.cost, it will give us output 0 and 0. But if we try to print name, it will give you an error. What error we will be saying that memory of instance variable is stored in heap data area. Memory of local variable is stored in stack data area. For instance variable like here age and cost, default values are given. For a local variable such that name, default values are not given. This is the second difference. Also, if we write dg.cost here and give it a value of 1999, okay, so cost is changing from 0 to 1999. I hope you understand the memory mapping of the program, how it works and all that things. Okay, so there are a difference between instance variable and local variable. I will be counting it for you once again. For instance variable, it is created directly within a class. For local variable, it is created inside a class within a method or loop or block or a constructor. What is constructor? We will be seeing. The memory allocation for instance variable is inside heap area within an object. The memory allocation for local variable is inside a stack area. If we declare our instance variable, then default values are given to it. But if we declare our local variable, no default values are given to it. Instance variable can be accessed anywhere within the class, also outside the class, but using that object reference. Okay, if the variables are not private, okay, that is the one condition. We will be seeing the private concept in our access modifier. Local variable can be accessed within a method only or a block only, wherever they are defined. Okay, so scope of for our local variable is local to that particular block. Let's take this one more example for our memory mapping. We have written one class called as calculator. It has a three instance variable num1, num2 and res, that is result. We have one method called as add, which has basically two parameters, int a, int b. We have assigned a value of a to num1, value of b to num2, and calculated the result of num1 plus num2 and store it in the variable of res. And after that we have printed res on our console. For that we first need to create an object for our calculator, right? And here we go, object is created. Okay, but to manage that object we need to create one reference variable. Let's say our reference variable is calc. One thing remains here, the type of a reference variable. So type is nothing but the calculator. Why calculator? I told you in previous video only, calc is storing the address for our calculator. Okay? So because of that, calc, the type of calc is calculator. We can directly call that add method, but before calling that, you can see there are some parameters, int a and int b, right? So we need to pass some arguments in that method, right? So for a we can pass 10, for b we can pass 20. So on our console we have successfully printing value of 30. But that's not our aim to create a calculator app, right? We need to discuss the memory mapping for this program, and just try to discuss the memory mapping. We have our stack area and heap area. We have our class calculator. First of all, the whole code, the dot class file, the byte code stores on the method area. From the method area, stack extract the main frame only and created it. In the main frame we have a calculator calc reference variable which stores the address for our calculator object. So calculator object is created. Object is always created in our heap area. We have num1, num2 and res, three instance variable defined. All have the default values 000 as they are int. In the next line we have calc calc.add, add method. Okay, so we have to create this add on our stack and pass 10 and 20 for our values of a and b. So a and b are nothing but the local variables 10 and 20. So from this line the execution will move towards the void add method. Num1 equal to a, so we have to assign a value of a, that is 10, to our num1. We have to assign the value of b to num2. So value of b is 20. We have assigned the 20 value to num2. After that we have to calculate num1 plus num2, which is nothing but 10 plus 20, which is 30. 30 is stored in our res variable. We need to print our res variable on our console. So 30 is printed. After that we have reaching the end of our method. So the execution is again go in the new line. There is end of our main. So JVM ends its execution. Okay, so if we create object or instance, memory is allocated in heap area. Remember this point. And if there is no reference referring to the object inside a heap area, then garbage collector will collect that object. Means what? Object memory is deallocated. What I am trying to say, after JVM ends the execution, mainframe gets deleted. We have also executed this add, so add method is also getting out of our stack area. So there is no reference variable referring to this object inside a heap area. Then garbage collector, this garbage collector comes into the picture and will collect the object. What do you mean by collecting the object? Object memory is deallocated from the heap area also. So stack is also cleared, heap is also cleared. Our JVM ends the execution. We have seen that after calling calc.add, we have to create a add method in our stack area. Okay, there is one error in our Java which is very famous, a stack overflow error. We will discuss this stack overflow error in our next video. So this is Coding CEO signing off. Keep coding, keep conquering, and keep being the CEO of your coding dreams. Thanks for watching.